Now that I've told you guys that I work at Meta, I think an interesting video for you would be what tech stack I use on a day-to-day basis in my work. To give you some context, I started my career as purely a back-end focused developer, but over time I've drifted into full stack development with a product focus. Let's talk about some of the tech we use here at Meta and what sort of things I'm building with it. Before we get into the video, shameless plug, like the video and please subscribe to the channel. Help me get to 10,000 subscribers. Alright, let's get into it. Let's start on the back end. In case you didn't know, Meta has their own programming language called Hack. It's a much improved version of PHP that was originally created because PHP just couldn't offer the performance or scalability required to serve a user base in the billions. Hack is statically typed, and this can make it a bit verbose, but it's not as bad as something like Java or C++. I think a lot of people worry about having to learn Hack when first coming to Meta, but this is not something you should be concerned with. Meta has invested considerable resources into making the Hack developer experience extremely smooth. The IDE integration we have into VS Code is snappy and feedback is rapid. Meta also has a ton of codegen scripts which will automatically generate most of the boilerplate and code artifacts you need. If you want to brush up on some Hack before joining the company, then check out the open source docs, but honestly, I learned Hack on the job without any prior PHP experience, and it was all super simple and straightforward. Following up on Hack, another thing that is extremely prevalent when coding at Meta is our Ent framework. The Ent framework is Facebook's own ORM system and is built with privacy in mind. Without going too much into the details, the whole premise of Ents is that certain users should or shouldn't be able to access certain types of data. There's a concept called a viewer context, which allows the objects themselves to essentially validate that the person trying to access a piece of data actually has the permissions to do so. Though you may think that Meta doesn't take privacy seriously given all the fuck-ups in the past, there are many systems in place to ensure that people only access what they should be able to, and Ents are just one of those systems. On a more general level, Ents allow you to do all the regular things you expect from an ORM. Though at Meta, we tend to think of our data as one big graph, and the end objects, there are edges to other ents which represent a relationship between the entities. Each ent defines its own schema, as you would with a regular ORM, and defines any relationships between objects, or edges like we just said that they're named. And then things like which database to store them in, or how to shard the data if the expected size is too large to fit on one machine. If you want to read more about Ents, Meta actually has an open source, watered down version of Ents as a Go package, which I'll link in the description below. As well as that, I'll link an article discussing Tau, which is one of the database options we actually have when choosing how to store our graph data. It's either that or MySQL. Another thing to talk about on the backend side is GraphQL. GraphQL is yet again another one of our open source releases, and it's a way of querying data from your backend in an optimized way. If you've never used GraphQL before, it can be a bit tricky to understand, but at a high level, GraphQL aims to prevent the issue of data underfetching or overfetching, and it does this by allowing you to specify exactly the fields you want to query from your ORM object instead of fetching all of them or not having enough of them exposed on a regular REST endpoint. This way, you're able to get exactly the data you asked for and no more or no less. And obviously, given the scale of the data flowing out of Meta servers, this is a big deal for us to be able to do. GraphQL pretty much powers all of Facebook and Instagram. Pretty much most data objects at the company are represented as Ents, which we touched upon earlier. And GraphQL allows us to write queries to expose endpoints which anyone can use, except they can then choose which fields they actually want for their use case. For example, if an ent has 20 fields in its schema, but you only need access to 3 of them, when you hit the endpoint to fetch all those objects, you can just specify those 3 fields you need on that object, and that's all that will be returned for the individual object. You don't have to worry about overfetching all other 17 fields, you just get the 3 you need and nothing more. I use GraphQL daily to define endpoints, which me and other engineers will be calling into on the front-end side of things, which we then use to build features. I'll touch upon how we do this in the front-end section of the video, as it's its own library that sits on top of GraphQL. If you want to work at Meta, I would definitely recommend you familiarize yourself with GraphQL and its basics, because it's definitely something that you'll be using on a daily basis. Unlike Hack, it can be a little bit tricky to actually wrap your head around it, and it's a new way of thinking about fetching data from the server, so it can be, like I said, a bit tricky. Let me know in the comments, do you guys want a Meta Engineer's Guide to GraphQL? If enough people are interested, I can definitely make some videos. When it comes to front-end, it should come as no surprise that Meta is using React. I say this because they're the company that open sourced the library, and it's safe to say that it's taken over the internet as the de facto king of front-end code. Sure, there's others like Vue, Svelte, and let's be honest, that pile of shit Angular, but React is king and I'm glad we use it. If you don't already know about React, the whole premise is that you can break down your front-end code into small, reusable components. This way, each piece of the UI can be contained in its own component, and this keeps things neat and organized. Plus, you get the added benefit of being able to use the component in multiple places. This way of doing things simplifies development because you can reason about problems and their data dependencies in isolation and keeps things clean and concise. On a more technical level, we aim to use functional React components wherever possible due to the nice hooks APIs, though there's a ton of legacy components still on the class-based system that are lingering around, and I've definitely had a headache of trying to refactor these in the past, and trust me, it's not fun. Meta also has a ton of internal component libraries, and these will pretty much take care of all the basic components you need on a day-to-day basis, buttons, tables, sliders, all that stuff, right? A lot of the work comes from taking a design spec from the product designers and basically transforming it into a real feature on the site using these base components. When it comes to actually getting data in and out of the front end, we use a library called Relay. Without getting into the details, Relay at a very basic level is the way that we communicate with our GraphQL backend and fetch data from the server. It's quite an interesting way of doing things because the library is very opinionated and strict on how you do things. It also compiles down all of your GraphQL queries that you've defined in your code in order to figure out the most optimal way to fetch the data from the server and avoid wasted packets for duplicate data. Relay is much too complex to discuss here, but if you want to be a full stack or a front-end developer at Meta, then this is definitely one thing you'll want to look up and learn before you join, because it's probably one of the harder things to get to grips with. In terms of data management, once data is already inside of a React application, we're now using Recoil, which is, surprise, surprise, another Meta open source library. It's super simple. You define these things called state atoms, and then you can access them anywhere you're in your code after you wrap the root component in a Recoil data provider. You can check the docs for more details, but this is basically the new best and simplest way of managing internal state in front-end applications, and thank God, because Redux was an absolute shit show and way too complicated. The final thing I want to touch here is that we use Flow as our type checker. If you aren't familiar with Flow, it essentially adds static typing to JavaScript code, which is extremely useful. And if you don't know anything about JavaScript, it's essentially the wild, wild west in its vanilla form and doesn't give a flying fuck about type safety, which is definitely not what you want in any sort of large-scale applications. Flow is essentially TypeScript, except Meta's version. Surprise, surprise, it's one of our packages again, and does the same thing, but there's some annoying differences, but these are easy to pick up. It's not something difficult to learn, but if you're coming from TypeScript or you have no experience in typed JavaScript before, you'll catch on quite quick. And a lot of the time, the Relay compiler that we mentioned earlier will actually auto-generate the type interfaces for you, so you rarely need to define complex shapes. Last part of this video is just going to be some honorable mentions, and the first one is going to be MySQL. This is probably the database that you're going to be working with most frequently here, but rarely do you actually need to write raw MySQL code. A lot of your interactions with the database is going to happen through the Ents framework, which handles the data fetching behind the scenes. If you ever find yourself needing to write big data queries, then you can use a query engine called Presto, which sits on top of our data warehouse and is quite insane. You can query petabytes of data in seconds because everything is stored in memory and partitioned in a way that makes fetching efficient. When it comes to source control, we use Mercurial. We've extended a lot of the core library to make it work with Meta's codebase size, and there's a ton of really great developer-friendly features baked in. You can actually use the same source control flow that we use by checking out the newly open source Sapling project. This exposes a lot of the same functionality and workflows, and one of the big ones is actually being able to write stack diffs, except for now it will work in Git and GitHub. When it comes to IDEs, the standard one that everyone uses is VS Code, but it's been modified with Meta internal tools and packages, so it's a little bit more powerful than the one you can download from the internet. We actually do most of our development on remote dev servers, and by clicking one button in VS Code, we're allocated and opened a connection to one of these servers for us to do our work on. Finally, one of the cool new tools we've been using in the past few years is something called Excalidraw. It's essentially a digital whiteboard and is really great for writing design docs because of how flexible it is. It's better than most of the tools out there, and it's completely free. Meta actually uses this for their system design interviews if you're doing it virtually, so check it out if you have one coming up. And there you go, that's the tech stack that I use on basically a daily basis in my role as a full stack developer at Meta. Obviously, I can't go through all of the things I do and all the technologies and go into detail on the ones that I do just because this video would be way too long, but if you have any questions or you want to learn more, then leave it in the comment section below, or why not join the Discord channel and ask me there. Otherwise, if you enjoyed the video, why not leave it a like and comment? It really helps me out with the YouTube algorithm. Subscribe to the channel if you want to see more content like this, and I will see you in the next video. Bye!